Okay, in these two, or in this video and the next one, we're going to talk about working kind of the opposite way, and that all the way along we've been saying the sine of an angle equals what? Well, now I'm going to say what angle would we put into the sine function to get 1/2. And I'm going to use the hand trick again. I'm a big fan of that. It's very quick and very easy. Now, of course, the hand trick always says it's the number, square root of the number of fingers divided by 2. Well, you can see we got the divided by 2 right here. So I'm not too worried about that. But what I need to do then is figure out how to get 1 on top. Well, the square root of what equals 1? It's 1. So I'm looking for what finger I would pull in that would only give me 1 finger below, because sine's below. Well, it's this ring finger right here. Then I just got the pinky below. Well, this is 0 pi over 6. It's the pi over 6 finger. Okay, so you'd say, oh, well, x is equal to pi over 6. That's right. The problem is, you see, I've given you a domain. I've said it's all the angles between 0 and 2 pi that fulfill this. And remembering what we know about the unit circle, the pi over 6 triangle is right over here. We get a height of 1/2, but that's not the only place that happens. That triangle occurs in each of the 4 quadrants. Now, since we're looking for when it's positive 1/2, I know it maybe would seem obvious even by the picture, but let me do the wrong answers first. If I built that pi over 6 triangle over here, the y coordinates are negative, so sine would be negative 1/2. Same thing if I did it here in the 4th quadrant, we'd have negative 1/2. So the only place where I'm going to get another positive y value, and remember the y coordinates match up with sine, the only place that's going to happen is in the 2nd quadrant. Okay? Now, since this is 6 pi over 6 right here, it's going to be 1 less than that. It's going to be 5 pi over 6 would be the other answer to this equation. So just be sure you check to make sure you got both answers. Now, the other way you could think about that is you could graph the line y equals 1/2 and think about, well, if I graphed y equals 1/2, go through right there, it would look something like that, and you could just find the 2 angles that would intersect that. So I don't think either one's necessarily easier than the other, but you get the idea. Now, the other one I put up here was cosine equal to negative square root of 2 over 2. Now, I'm not going to worry about the negative yet. Okay, I'm not going to worry about it. I'm just going to worry about the absolute value and knowing that it's square root of 2 over 2. Now, the over 2 part, it's always the square root of fingers over 2, so I'm not going to worry. We got that. But I need a place where I have 2 fingers above. Well, if I pulled in that middle finger, I'd have the 2 fingers above. Remember, it's 0, pi over 6, pi over 4. Now, I'm just going to kind of write right here, kind of bracket. I'm going to write pi over 4 because I know it's got to be some multiple of that. However, in the unit circle, remember that pi over 4 is right up here. Well, the x and y coordinates are positive there. So cosine wouldn't be negative square root of 2, it would be positive. We've got to look for the multiples of pi over 4 that are negative. Well, remember x coordinates go with cosine. Okay, so the x's are negative over here, so I'm going to need a pi over 4 there. Okay, some multiple of pi over 4, I'm going to need a pi over 4 there. I'm going to cross that one out because that would be positive. So remembering that this is 2 pi over 4, and this is 4 pi over 4, and this is 6 pi over 4 down here, we can easily pick out our multiples of pi over 4. 2 pi over 4, this is 3 pi over 4. 4 pi over 4, this is 5 pi over 4. So those are our 2 answers. 3 pi over 4 and 5 pi over 4. Those are the 2 angles we could put in that would give a cosine of negative square root of 2 over 2. Now, this has not been a big part of pre-calc, and it wasn't a big part of calculus until this appeared last year on the AP exam. So it's really important. It's not that hard to do, but it's really important to know how to do this without a calculator. In the last video, I'm going to show you how to do a couple of these that are a little more difficult, including the one that was on the AP exam last year.